Hello. Today I'm going to take a look at the final lab in our expose on density. This is temperature affecting density. All right. See how long it takes us, see how far it gets. All right. The previous one we looked at what floats in water. Today what we're going to do is see the arrangements of atoms and molecules in liquids and explain how temperature affects the density of liquid water, hot and cold water, molecular level to understand about why the temperature affects water, and how it affects its density. All right. Hot and cold water added to room temperature water.
Is there a density difference between hot and cold water? Here we have a cup of room temperature water. First, we will add cold water to this cup. It has been dyed blue to make it clearer for you to see. Notice what happens to the cold water when it is added to the room temperature water. What does this tell you about the density of cold water? Now, we'll add hot water to the room temperature water. The hot water has been colored yellow. Where does this hot water go? What does this tell you about the density of hot water compared to the density of room temperature water?
Cold water sinks and hot water floats. All right, in the video, cold water blue sank in the room temperature water. That means the cold water is more dense than room temperature water. The hot water yellow floated. So that means the hot water is less dense. It's easy. Water at different temperatures.
Let's look at an animation of cold water, room temperature water, and hot water and compare it at a molecular level. Right now, we're looking at room temperature water. This sample is 25 grams of room temperature water, and as the graduated cylinder shows, it takes up 25 cubic centimeters of space. Therefore, the density, mass divided by volume, is 25 grams divided by 25 cubic centimeters, and the density of this room temperature water is 1 gram per cubic centimeter. Now take a look at the animation of the molecules. You'll notice that they're moving, they're sliding around, and there's a certain spacing between them. Now we've cooled the sample down. If you notice carefully, the space between the molecules is smaller. They've moved closer together, and they've also slowed down. As they've moved closer together, the volume of the sample has dropped from 25 milliliters down to 24 milliliters. The density is now mass 25 grams divided by volume 24 cubic centimeters, and that is a density greater than 1. It is 1.04 grams per cubic centimeter. Because it is denser than room temperature water, cold water will sink. Now let's switch and take a look at hot water. In hot water, the molecules are moving much faster, and they have more energy, and they spread a little bit further apart. Therefore, the volume of the sample goes up. The volume has increased to 26 cubic centimeters. The mass has stayed the same, 25 grams, at all of these temperatures. We are not losing any water molecules, so that's expected. But as the temperature changes, the volume changes. And because the volume changes, the density changes. The density here is 25 grams of mass divided by 26 cubic centimeters of volume for a density of 0.96 grams per cubic centimeter. The density of hot water, therefore, is less than the density of room temperature water, and so hot water will float. Taking a look at the molecular level, you can understand why hot water floats and cold water sinks.
Okay. In the animation, the molecules of hot water move faster and further apart, so they take up more room than the room temperature. If the hot water takes up more volume, the mass volume the ratio is going to get smaller. So that means it's going to be less dense. And the cold water moves slower. We got closer together. So that means that the mass volume
difference between hot and cold water. We're going to place one jar filled with hot, yellow colored water upside down over another jar filled with cold blue water. Do you think the hot and cold water will mix or stay separate? Right now, we're picking up the yellow hot water jar and putting it on top of a waxed card. We'll put the yellow hot water above the blue cold water and remove the card between them. See what happens.
blue is going to go to yellow, yellow is going to go to blue, and then eventually over time it's going to mix to get green.
Although removing the card resulted in a little mixing and a little spilling, the hot yellow water remained in the top jar and the cold blue water remained in the bottom jar. Now, let's flip it. This time, we'll take...
Sorry. What I said was it's going to flip. That's because the cold was on the bottom. If the cold's on the top, it's going to change. I'm sorry.
blue cold water and place it on top of the hot yellow water. What do you think will happen? We followed the same procedure. The card is removed so that the blue cold water comes in contact with the yellow hot water. This time, the result is very different. When the cold water is placed on top, the colors mix because the cold water is more dense and sinks in the hot water.
Yep, it's going to go green. Yay! True or false, in the video, the hot water stayed on the top of the cold water. Very little mixing. Yes. And the cold water stayed on top of the hot water with very little... What? The hot water stayed on top of the cold. Yes. The cold water stayed on top of the hot. No. All right. Use what you know about the density of hot and cold to explain what happened during both experiments. Hot water rises over colder, more dense water that sinks. That's why. Hot water. Yeah, that's about right. Staying on top. Yep. Cool. That's it. All right. And that's the last one of our our lessons in middle school chemistry. So these are the last of the videos that I'll be doing for this type of activity. So a moment for the greatness that was this this program. And now you're going to have to deal with me creating everything. Have a nice day, guys.